So this is just a quick overview about how we work with the data after we recorded it. And what you look at here is a 300 microliters sample dispersed in the wet dispersion aid of the SPE, the single particle explorer. And we have measured in total 200 particles on that surface here. And some of those particles, since we had a highly concentrated monoclonal antibody solution, some of those particles represent agglomerates of that very same monoclonal antibody. And since the sample was over the shelf life, we also find several fatty acid particles that come from polysorbate hydrolysis, or that were polysorbate hydrolysis product. We have limited the analysis to 200 particles. We do see a particle size distribution here, and we have set up the analysis in a way that we come from the largest to the smallest particle. So when you take a look at the particle size distribution, we start to see some particles between 50 and 100 micrometers. So there were 91 particles between 20 and 99 or 100 particles between 10 and 15, and 353 between 5 and 10, and nearly 1000 between 2 and 5. The particles are counted in dark field mode, that's what you see here, and we know the particle's location. So, for example, the 7 largest particles are these particles here, and they were all analyzed. 2 of them were extrinsic materials, such as fibers or other types of materials. 1 and 5 of them were found as monoclonal antibodies. And you see them here, those 5s. We can go through them and take a look at those different particles. Now, more interesting it becomes when we look into that size channel here. And here we see a mixture of, that's just the background signal. That's a monoclonal antibody. That's something extrinsic like cellulose. You see that on the broad peak here. And some monoclonal antibody material, and again some cellulose material. And that's how the instrument differentiates one and the other. In this experiment, what was very interesting was the fatty acid particles. And there were in total 7. And when it comes to these fatty acids, you could see that on the wet dispersion aid bottom, they form these straight lines, which is kind of surprise, but that's how they orientate themselves or organize themselves in the wet cell, and you can now clearly see them. That's a single one that has a diameter of 21.8. We have one here with 21.4, some with 15, some with 11, 6. So with that demonstration, we can show you that down to very small particle size of 4 micrometers, we can reliably identify fatty acids in a highly concentrated protein-based formulation. In this example here, which is another file, and by the way, this is the format how you can reprocess data once you have recorded it with the single particle explorer. Now here we have in total 1680 particles. All analyzed particles are highlighted now, and there were some larger air bubble regions. That's what you see here, and we see some smaller particles, and we were more interested in the smaller ones than in these air bubbles. Let's take a look at this example, because here in that example this was a pre-filled syringe. Here you see the silicone oil droplet, and you can clearly see that those 2 peaks here at 500 and 700, these are related to silicone droplets. And going down to the smaller ones, so that's 5.7 micrometer silicone droplet. This is 5.4, 5.2, and 5.0. So you can reliably find those silicon droplets, and you can even measure smaller ones. We have measured them in other examples down to 2 micrometers in size. Thank you very much. Bye bye.